So this video will be on titrations, and firstly we'll have to analyze the question to see what type of titration will be taking place. So we have 3 chalk pieces of identical composition and mass, like that. We have hydrochloric acid solution and we have a sodium hydroxide solution. So it looks like it'll be a double titration from the start of the question. It says use the mean titer to calculate the percentage of calcium carbonate in the chalk sample. So we have the titers here, and then we have the mean titer here. And so this is the equation between the chalk piece and the hydrochloric acid. So we see that it's just quickly label it's a 2-to-1 ratio. So remember that for later on. It says that using this in the student's results, including the mean titer of 16.4 centimeters to calculate the percentage of calcium carbonate in the chalk sample. So first what we do is we write out the mean titer of 16.4 centimeters cubed, which we will change to decimeters, so it's 0.0, so it's 100 milliliters, that's 10, so it's 0.164 decimeters cubed, NaOH, because you can see here, titrate against the sodium hydroxide solution. So that's how many decimeters of sodium hydroxide solution was needed to neutralize the remaining acid. And so we need to work out the moles of NaOH, which would be the CNV, so CNV, like that, so 0.0164 times the concentration of NaOH, which is 0.1. So we have 1.64 times 10 to the minus 3 moles of NaOH, and this means that we can now relate this to our moles left over of HCl, HCl. So HCl plus NaOH gives us NaCl plus H2O, which means this is a 1-to-1 reaction. So that means if we have 1.64 times 10 minus 3 moles HCl2, and this means that we can now relate this to our moles, total moles of this. So to work out the total moles of this, we need to do 0.05 because we have 50 centimeters here, times by 1, because it's a 1 mole per decimeter cubed. So that's equal to 0.05. And then we're taking away our moles that were left over to work out how many moles were actually used. So we have, take away 1.64 times 10 minus 3. So if we put that in the calculator, we get 0.04836 moles HCl used in the initial reaction, which is this one. And because it's a 2-to-1 ratio, we have to half this, so divide by 2 equals 0.02418, and this is the moles of CaCO3 that were used in the reaction, and Ca is 40, so we have to times this by 40, and C is 12, so 40 plus 12, and then we have O3, what was it, O3, which is 48. And this will give us our mass in grams of pure calcium carbonate, and it's equal to 2.418 grams. That's the mass of purity. So then we have 2.48 over the unpure mass, which is 2.54, times 100 gives us our final percentage purity, which is 95%.